Welcome to my class 12 physics, chapter ray optics, and today we will discuss about spherical mirror and some terms connected with the spherical mirror. Clear? And you know all about your plane mirror. Plane mirror means its surface looks like a plane, and one side of the plane mirror, that is silver coated or coated with silver, and that is known as the non-reflecting surface, and another side that is the glass surface, that is also a plane surface, and that is known as the reflecting surface. One is a non-reflecting surface, other side that is the reflecting surface, and surface is a plane one, so that is known as the plane mirror. But in case of spherical mirror, surface is not a plane surface, surface looks like a curved surface. Clear? In case of spherical mirror, surface looks like a curved surface. And generally spherical mirror are two types. One is concave spherical mirror and another is convex spherical mirror. First we take a hollow sphere. We take a hollow sphere. Suppose this one is a hollow sphere. Here two surfaces are there. One is your inner surface and another is your outer surface. And this hollow sphere made up of glass, material is glass. And this point is the center of the hollow sphere. And center of the hollow sphere we write, suppose that is C. C for center of the hollow sphere. And we take a part of this hollow sphere. We take a small portion or a part of the hollow sphere, just like this. We write, suppose that is xy. And if outer surface, this is the outer surface, if outer surface of this part is coated with silver, then this outer surface is now non-reflecting surface. This outer surface we know that is the non-reflecting surface. That is the non-reflecting surface. And this is the inner surface. And the inner surface is the reflecting surface. If inner surface of the hollow sphere made up of glass is a reflecting surface and outer surface that is the non-reflecting surface, this type of spherical mirror is known as the concave spherical mirror. We write that is concave spherical mirror. Clear? That means simply we write here reflecting surface, reflecting surface means this inner surface is curved inward. If reflecting surface is curved inward, if reflecting surface, this one is the reflecting surface, if reflecting surface is curved inward, then the spherical mirror is known as the concave spherical mirror. Clear? Similarly, second type, we take another hollow sphere. Just like your first one. Suppose this one is a hollow sphere, same thing, just like first one. And this point is the center of the hollow sphere. For center of the hollow sphere, we write C. Here also material of this hollow sphere, that is glass. Here also two surfaces are there. One is the outer surface and another is the inner surface. And we take a small part or a part of this hollow sphere. Suppose this is the part of the hollow sphere and we write that is suppose xy. And in this case, suppose inner surface of the hollow sphere is coated with silver. If inner surface of the hollow sphere is coated with silver, then what happen? Here this inner surface we write that is the non-reflecting surface. This inner surface is the non-reflecting surface, and this is the outer surface, and outer surface is the reflecting surface. This outer surface we write that is the reflecting surface. Clear? That means if outer surface is reflecting surface, inner surface that is the non-reflecting surface, and here this reflecting surface is curved outward direction. So that this type of spherical mirror is known as the convex spherical mirror. We write that is convex spherical mirror. Clear? Here also we write same thing, just like that one. Here reflecting surface. Here reflecting surface is curved outward. Simply, if reflecting surface is curved outward, or outer surface is the reflecting surface, that is convex. If inner surface is the reflecting surface and that is curved inward, that is known as the concave spherical mirror. Clear? Now, some terms connected with the spherical mirror. First term, that is pole. First term, that is pole. Simply write capital P, P for pole, P for pole. Look at the figure. Here, starting point is X and the last point that is Y, and this is the reflecting surface. This inner surface is the reflecting surface, and this point is the center. This point is the center of the reflecting surface. Here also same thing. Here outer surface is the reflecting surface, and this point is the center. This point is the center of the reflecting surface, and this is center of the reflecting surface. We write that is P, P for pole. Here also center of the reflecting surface. We write that is the pole, and this pole is situated on the reflecting surface, not outside. Clear? Here also pole is situated on the reflected surface, that means on the mirror, on the spherical mirror. Pole is always situated on the reflecting surface, not outside the spherical mirror. Clear? So that we write pole means that is the center of reflecting surface. Center of the reflecting surface, simply we write that is pole. Clear? Then second term, that is known as the center of curvature. Center of curvature. For this we write capital C, C for the center of curvature. Again, look at the figure. This point is the center of this whole sphere. This point is the center of the sphere, and this reflecting surface or this spherical mirror, this reflecting surface of the spherical mirror is a part of this whole sphere. This reflecting surface of the spherical mirror is a small part of this whole sphere, so that this center of the sphere is known as the center of curvature of this spherical mirror. Same thing, just like concave, here also same thing. This point is the center of the whole sphere. This point is the center of this sphere, and this reflecting surface or this spherical mirror, this reflecting surface of the spherical mirror is a part of this sphere, so that this center of the sphere is known as center of curvature of this spherical mirror. Clear? And simply write center of sphere of which reflecting surface of spherical mirror, reflecting surface of spherical mirror forms a part is called center of curvature. Clear? Is called center of curvature. That means same thing. Center of the sphere is known as the center of the curvature. Very simple. Similarly, we join from the center to the pole, and you know this is the radius. Similarly, here join from the center up to pole, that is the radius. That means this one C to P, this one is the radius of this sphere. C to P, this is the radius of the sphere. This one is the radius of the sphere, and this reflecting surface of the spherical mirror is a part of this sphere. So that this radius of the sphere is known as radius of curvature of this reflecting surface of the spherical mirror. Clear? This radius of the sphere is known as radius of curvature of the spherical mirror. Very simple. Radius of sphere is known as radius of curvature of the spherical mirror. And for this, we write that is the capital R, that is radius of curvature. For radius of curvature, we write that is the capital R, and simply write its definition, that is radius of a sphere of which reflecting surface of the spherical mirror, reflecting surface of the spherical mirror forms a part is called radius of curvature. Very simple. Radius of curvature. Simply radius of the sphere is known as the radius of curvature of the spherical mirror. Clear? And another term, that is aperture. And we write that is xy. Aperture, that is xy. Then what is aperture of the spherical mirror? Look at the figure. Here, x to y, this is the reflecting surface. This inner surface is the reflecting surface in case of concave, and here this outer surface is the reflecting surface. But the outline of this reflecting surface, here also outline of this reflecting surface looks like circular. Just like this. Suppose this one is a curved one. This one is the curved one. This is not a plane surface. And suppose your material is a glass, and this is a small portion. This is a part of the hollow sphere. This one is a part of the hollow sphere. Clear? And same thing. This is the inner surface, and this one is the outer surface. If outer surface is coated with silver, then we say that this is a concave mirror. And if the inner surface is coated with silver, and this is a convex mirror. Clear? And here, this is the outline. And this outline looks like a circular one. And this is the diameter of this outline. This is the diameter of the reflecting surface. And this diameter is known as the aperture. Clear? So that simply write aperture means diameter of the reflecting surface we write diameter of reflecting surface of spherical mirror. Diameter of the reflecting surface of spherical mirror is known as the aperture, and here x to y, this is the aperture. X, y, this is the aperture of the concave mirror. Here also same thing. X, y, this is the aperture of the convex spherical mirror. Clear? Next point. Next point, that is number E. We write that is focus, and for focus we write that is capital F. For focus we write capital F. First we draw a concave spherical mirror. Suppose this one is your concave spherical mirror. This one is your concave spherical mirror, and your outer surface is coated with silver. If outer surface is coated with silver, now this is a concave. This is a concave spherical mirror, concave mirror, and this point is the pole. For pole we write the P, and we draw a line passing through this pole. Simply we draw a line passing through this pole, and this point is the suppose this point is the center. This point is the center, or we write that is the center of curvature. Clear? And this is the line. This is the line passing through the center of curvature and pole. And this line is known as the principal axis. Principal axis means line passing through the center of curvature and pole of the spherical mirror. And this line is known as the principal axis. And here we draw the parallel incident rays. Suppose this one is the first incident ray. This one is the another incident ray. All are parallel to each other. If incident rays are parallel to each other, then object is situated at infinite. If object is situated at infinite, then incident rays are parallel to each other. Then what happens? After reflection from this point, suppose this one is the first incident ray. This is the direction. Suppose this one is the another incident ray. So here total 5 number of incident rays are there. Then what happens? From this point, the ray is returned back into the same medium, because the incident ray suppose situated in air medium. Then from this point, the ray is returned back, and here we applied the laws of reflection. First we draw the perpendicular. First we draw a perpendicular to this surface, because this one is your mirror. At this point, this is the point of incidence, and you draw a perpendicular, and you know this perpendicular passing through the center of curvature. This is the perpendicular. At this point, we draw the perpendicular. Then this is the angle of incidence. For angle of incidence, we write I. With the same angle, the ray is returned back into the same medium, so that we draw the reflected rays. This is the reflected ray. This one is the reflected ray, and this is the angle of reflection. And angle of incidence is equal to angle of reflection. Clear? That means the reflected ray meet at a point, and that point is situated on the principal axis. Similarly, we draw other reflected ray. This one is the incident ray, and from this point the ray is returned back into the same medium, and the reflected ray moves in this direction and meet at the same point. Here also this is the reflected ray, and this is the reflected ray, and look at the figure. Here all the reflected rays all the reflected rays after reflection meet at a common point, and that common point is situated on the principal axis. So that this point is known as the focus. This point is known as the focus. Clear? And in case of concave mirror, focus and center of curvature both are situated in front of the reflecting surface, because this inner surface is the reflecting surface, and focus, center of curvature, they are situated in front of the concave mirror. Clear? That we simply write, if incident rays are parallel to the principal axis, after reflection, all the reflected rays meet at a common point. That point is situated on the principal axis, and that point is known as the focus, or that is also known as the principal focus. For this we write capital F. Clear? And after reflection, here all the reflected rays converging with each other. Converging means distance between the two rays is gradually decreased. Distance between the two rays is gradually decreased, and they actually meet at a point. So that is known as the converging. And the reflected rays are converging. If reflected rays are converging, concave mirror is also known as converging spherical mirror. Concave mirror is also known as the converging spherical mirror. Clear? Similarly, for convex, suppose we draw the convex mirror. And your inner surface is coated with silver. This is the inner surface. Inner surface is coated with silver. And this side is the outer side. Outer surface is a reflecting surface. Inner surface is coated with silver. And this point is the center of the reflecting surface. You know that is a pole. And here we draw a line passing through the pole and perpendicular to the pole. And this point, suppose your center of curvature. And this line is passing through pole and center of curvature, so that this line is known as the principal axis. This line is known as the principal axis. Clear? Line passing through the center of curvature and the pole of the spherical mirror is known as the principal axis. And same thing, here also we draw the parallel rays to the principal axis. Suppose this one is the first ray. Similarly, you draw the parallel rays. These are the incident rays. If rays are parallel, you know object is situated at infinite. Just like this. This is the object. This one is the object. For object we write that is, this one is the object. This is the head of the object. We write that is AB. AB is the object. If object is situated at infinite, then incident rays are parallel to each other. Then after reflection, what happened? This is the point of incidence. First we draw the normal to the spherical mirror at this point. So that we draw the normal, and this is the normal, and you know perpendicular or normal is passing through the center of curvature. This is the normal, because radius is always perpendicular to the surface, and this is also the radius, this point to this point. This is the radius always making an angle 90 degree or perpendicular to the surface, you know that. So that here this is the angle of incidence, I, with equal angle, the ray is returned back into the same medium, and draw the reflected rays. We draw the reflected rays, and this is the reflected ray. Clear? This one is the reflected ray, and this is the angle of reflection. We write R. Similarly, we draw other reflected rays. This is the reflected ray for this incident ray. This is the reflected ray, and this one is the reflected ray. Clear? And if this is the incident ray, if this ray is the incident ray, then the ray return back on the same line. You know that. And yet all the reflected ray is gradually diverging. That means the distance between the reflected ray is gradually increased. If distance between the reflected rays is gradually increasing, we write these are known as the diverging reflected rays. And in this case, all the reflected rays cannot meet in this side, so that we extend all the reflected rays in the backward direction. If we extend all the reflected rays in the backward direction, this reflected ray meet at this point on the principal axis. If we extend this reflected in the backward direction, if we extend these reflected rays in the backward direction, look at the figure, all the reflected rays meet at a common point, and that point is known as the focus. Here all the reflected rays, if we extend in the backward direction, all are meet at a common point. That point is situated on the principal axis, and that point is known as the focus of the convex mirror. Clear? And in this case, all the reflected rays appears to meet at this point. Or you also write all the reflected ray comes from point F. Clear? Appears to come from the point F, or appears to meet at this point. So that this point, this focus is not a real one, but this focus is a real one, because they actually meet at this point, and they appears to meet at this point. And in case of convex, this one is your convex mirror. This one is your convex mirror. In case of convex mirror, your focus and center of curvature all are situated behind the mirror. Clear? Focus and center of curvature situated behind the spherical mirror in case of convex, but in case of concave, focus and center of curvature they situated in front of the spherical mirror. Clear? And last point, that is the focal length. And here this point is F, this point is P. We measure from P to F. This is the distance. Between pole and focus. Here also same thing. P to F, this is the distance between pole to focus. And for pole to focus, we write the distance. The distance is known as the focal length. And for focal length, we write small f, or simply we write distance between pole and principal focus. Pole and principal focus of the spherical mirror. Is known as the focal length. Clear? And you know the principal axis. Principal axis means this is the line passing through the pole and center of curvature. That is the principal axis. Clear? Once again, this one is your concave mirror. Concave mirror is known as the converging mirror, because your reflected rays are converging. And this is the convex spherical mirror, and convex mirror here reflected rays are diverging with each other. So that convex mirror is also known as the diverging spherical mirror. Clear? And here this point is the pole. Pole is the center of the reflecting surface, so that is known as the pole. This point is the center of curvature, that is the center of the sphere, so that is known as the center of curvature. And P2C, this is the radius of the sphere, or you also write PC, that is the radius of curvature. For that we write capital R. Then this point is the focus. Focus means after reflection all the reflected rays actually meet at this point in case of concave, and in this case they appears to meet at a point. That point is known as the principal focus. And your focal length means from the pole to focus, distance between pole to focus is known as the focal length. Clear? And this is all about your spherical mirror. And in the next class we will discuss about sign convention. of spherical mirror.